Okay, so this time we have a converging lens. We're given an object of a given height. It's placed a given distance from a converging lens with a focal length that's given. So we have the height of the object, the focal length, and the object distance. So let's ray trace this as we've done before. Slightly different diagram here. Now we have a lens instead of a mirror, but a lot of the principles are exactly the same as they've been before. So we're going to have three rays that we're going to trace. One of them is going to be the undeflected ray, and that is going to go straight through the lens like this. All right, so that's number one. That's the undeflected ray. Now, the other two rays, just as when we had mirrors, they're going to be kind of paired off. In each case, there's going to be a parallel beam, a beam parallel to the axis, and there's also going to be a beam that goes through a focal point. So let's start with the one that comes in parallel. So here we go. We've got incoming parallel like this. We'll call this number 2. I'm marking these just to make it consistent from case to case and so that you can remember what these different cases are. You don't have to put those numbers on your ray diagram. Now I'm going to go through the focal point, and the thing to ask yourself is, does the ray bend towards the axis or away from the axis? And you can answer that by the fact that this is a converging lens. It tends to bring things closer to the axis. So that means in this case we're going to have a beam that does this. Let's see here. Kind of like this. Oh, and these two beams are coming close but not quite matching. All right, that's probably a good sign, I guess. And the third one is going to be a ray that is going to be parallel outgoing. So let me scooch this up a little bit. It's going to be parallel outgoing. And it's these two seem to be joining up somewhere around here, which is where the image ought to be. So that means I should expect a parallel beam coming along the bottom of the page. Now, I said before that for every one of these rays that has a parallel side, there's going to be the other side goes through the focal point. So if I have this beam go through the near focal point like this, until it hits this lens, then it's going to come out like this, and it seems to be off the page. I just did a horrible job of using my of making my scales on this one, but you get the idea here. Now, for this problem, well, let's see what this thing says here. What kind of image are we going to have? We're going to have an image over here somewhere. It's going to be real rather than virtual. It's going to be inverted. And is it going to be enlarged or reduced? Here's the original. It's going to be much larger than that in size, so it's going to be enlarged. That's the ray tracing. I'll stick to narration of the PowerPoint for the use of the lens equation, the equation formerly known as the mirror equation. I can use it for either mirrors or lenses. I'll do that in the PowerPoint narration.